Let's try and solve another problem today. Are you ready? Lesson 3, Equivalent Fractions with Chocolate. The problem reads, Mrs. Numbers asked her students to find how much of a candy bar each student will get if there are 4 candy bars and 12 students. Kate's answer is 2/6. John's answer is 1/3. Lynn's answer is 4/12. Who is correct? Before we get started, I want to remind you of what we learned in our first and second lessons because we're using the same type of candy bar for this problem. In the first problem, 3 people were sharing one candy bar, and we found that each person gets 1/3 or 1/3 of the candy bar. The numerator tells how many pieces each person gets, and the denominator names the total number of pieces. We also learned that a fraction with a 1 in the numerator is called a unit fraction, since it always names one unit. In the last problem, we compared how much chocolate you would get if you were sharing with 2 other people and how much you would get if you were sharing with 3 other people. If 3 people share, you get 1/3. If 4 people share, you get 1/4. And 1/3 is actually a bigger piece of chocolate than 1/4. So we know that sharing with less people means you get more chocolate. In math, the word compare is used to tell if the numbers are greater than, less than, or equal to. 1/3 is greater than 1/4, since 1/3 of the candy bar is more chocolate than 1/4 of the candy bar. Today, our problem is a situation where a teacher wants the students to solve how much chocolate each person gets when 12 people share 4 candy bars. There are already answers given by students, so we just need to check the answers and see who is correct. Since we have 4 candy bars in the problem, let's represent them with our 4 candy bar pictures. If there were 4 people sharing these 4 candy bars, each person would get one whole candy bar. But there are 12 people sharing. So we know we'll have to break apart these candy bars into smaller pieces to make sure everyone gets an equal share. Here are the 12 people and of course the 4 candy bars. Let's get these bars partitioned and see what fraction of a candy bar each person gets. We're going to blur out the candy bars so that we don't have to use the lines that are already in the chocolate. Starting with 2/6, which was Kate's answer, let's see what it might look like and check and see if she's correct. 6 in the denominator means that the candy bars each need to have a total of 6 pieces. We can draw lines this way, horizontal, or we can draw them this way, vertical. The horizontal lines are skinny, long pieces, and the vertical lines are shorter and wider pieces. You might be wondering if that would be fair. Are those pieces really the same amount of chocolate? It's hard to compare things like this, but I'm here to tell you if those candy bars are the same size and those 6 pieces are partitioned with lines that are exactly the right distance apart, then those have to be the same size pieces. Even if they don't look like it, those are the same amount of chocolate. They are equal. Now, we'll use the lines going in the vertical direction, but it's really up to us. Each candy bar is partitioned into 6 equal pieces. Now we need to count out the pieces and see if we give each person 2 of them. Will there be just the exact amount needed so that everyone gets 2/6 of a candy bar? If the faces are moved over the models, the heads are the right size that they each cover 2 pieces. Do you see that? That works out nice. So if each person gets 2, we can see that all 12 people get 2 pieces. That means that Kate's answer is correct. 4 candy bars, 12 people, each person gets 2/6 of a candy bar. 2 in the numerator names how many pieces each person gets. 6 in the denominator tells you how many pieces each bar needs to have. If you ever forget which is the top and which is the bottom, you can use something that my 3rd grade teacher told me that I will never forget. Denominator starts with the letter D, and down starts with the letter D. So denominators are the down number, the one on the bottom. You might be tempted to stop here, We know Kate was correct, so we have the answer, right? Well, we also know how tricky the people who write these questions are. They are always trying to get us to do tons of work and then skip something and get it all wrong anyway. Well, not today, my friends. We are putting a little check in a circle around Kate's answer so that we remember she was correct, and we are moving on to check the rest. The problem never says there's only one correct answer, right? It is possible there could be more than one person who got it right. Let's just try and find out. We are moving on to see if John is correct with his answer of 1/3. 12 people, 4 candy bars. Any ideas how many pieces we need to show on each bar this time around? If you are thinking 3 because there's a 3 in the down denominator, then you are thinking the same thing I'm thinking. 3 equal pieces on 4 candy bars. Let's see if each person gets 1 piece like John says in his numerator. It turns out that yes, John is correct. How many pieces each? 1. How many total pieces on a bar? 3. Extra credit, do you remember what it's called when each person gets 1 piece? Now we know that Kate is correct and John is correct. They are both correct, even though they have different answers. Interesting. We better check out Lynn's answer. Let's mark John with the check mark and do this whole thing again one more time. Lynn says the answer is 4/12. So how many pieces do we need on each candy bar? That down denominator again, 12. 12 pieces, 4 pieces for each person since there's a 4 in the numerator. Since each up and down column on the bar has 4 pieces, I'm going to give each one of these faces one whole column. That will make it easier to not get mixed up. So if you get all these 4 and you get all these 4 and so on for every single one of the 12, they should all get 4 pieces. Look at that. Lynn is correct as well. She gets the white circle and check, and we need to think about this. Looking at this big chocolate bar, you can see that there are 12 equal pieces. If we shade 4 of them, our fraction is 4/12. Lynn's answer. If that works, why does 1/3 also work? If I leave the shading there and just take away the horizontal lines, I've changed the fraction to 1/3, but it's still the same amount of chocolate. That means that 4/12 and 1/3 are the same amount of chocolate. They're equal. The same amount of chocolate, but we call them by different numbers because you can cut up the chocolate or maybe it breaks, but it's still the same amount. The math name for this is equivalent. What about 2/6? If I leave the shading there and just put in one horizontal line, I create 6 equal portions of chocolate, and the shaded portion covers 2. So the same amount of chocolate again. So 2/6 is also in this little family of equivalent fractions. Let's look at our original candy bars again and see how it looks to show each fraction represented on the actual chocolate. You can see that the top candy bar has 3 pieces that are the same size. If you get one of these big chunks of chocolate, you get 1/3 of the bar. If you look at the middle candy bar, there are 6 equal pieces. But if you get 2 of the pieces, you are actually still getting that same amount of chocolate, 1/3. If you look at the bottom fraction, 12 equal pieces on the candy bar, but you get 4 pieces. So you are actually still getting 1/3 of that candy bar. If we go back to the problem that made us go through this whole thing in the first place, we have to find a solution for this. We have to say who is correct in this situation. And in this case, all 3 people are correct because 2/6, 1/3, and 4/12 are all equivalent fractions. If you have any questions or you need more practice with fractions, you can go to our website, asktheteacher.net. You can also follow us here for more videos. Until next time.